All right, guys, this is chapter one, statistics note cards. So let's read some of the introductory information here. Same information you get out of your textbook. But it says individuals are the objects described by a set of data. Individuals may be people, and if that's the case, they would be called subjects, animals, or things. Okay, next it says a variable is any characteristic of an individual. Okay, a variable can take different values for different individuals. So we have two main types of variables that we're going to talk about. All right, and these are the two types. Categorical variables are variables that place individuals into one of several groups or categories. That's why it's called categorical. And quantitative variables take numerical values. Okay, so quantitative, numerical values, categorical, okay, places them into several groups or categories. And the distribution of a variable tells us what values the variable take and how often it takes these values. So let's look at the first example. Okay. First example here is college majors. So this chart down here is called a distribution. Okay, it's the distribution of bachelor's degrees awarded in 2010. So you have what people majored in, what students majored in, and the number of degrees. And then they also put that in terms of percentages. Okay, so 21.7% of undergraduate degrees awarded went to people who majored in business. So what are the individuals being measured? You might think it's students, but it's actually not students. What's being measured is the degrees. How many degrees were awarded? Okay, so the individuals being measured are degrees. Now for each degree, it's broken up into a certain type of degree. Okay, here's what the types of degrees. So the variable that's being measured is the major, okay, the college major that the degree was awarded in. Okay. So these things are definitely not quantitative. These are different categories that the degrees fall into. So this is categorical, because degrees awarded fit into groups by major. Let's go on to the next page. So now in section 1.1 in your text, the title of that is Analyzing Categorical Data. So the focus here is going to be just on categorical information. Okay, so if we want to display categorical data, we have several ways to do that. We have different types of graphs to assist us. All right, so in a pie chart, we use pie charts when we want to emphasize each category's relation to the whole. So kind of like in the last example, I could take a circle or a pie, and since all the degrees add up to 100%, we could break that up into the pieces that represent how much of each part makes up of the whole. On a bar graph, what we do is kind of looks like that, but those don't necessarily add up to 100%. Okay, maybe this is like the customer satisfaction for Ford, Toyota, and I don't know, Hyundai. And maybe Ford's customer satisfaction is like 90%. Maybe this one's 80%. Maybe this one's 70%. So these bar graphs don't necessarily have to total 100%. And they can be in terms of counts, not necessarily percents. It could be counts or percents. And the last way we can do this is, okay, we can make what's called a two-way table, and that's a table that describes two categorical variables in counts or percents. So we're getting a little bit ahead of ourselves, but this down here is actually a two-way table. Okay. Now when we want to analyze categorical data, the easiest way to look at data is in a two-way table. We'll be talking about several terms here. Excuse me. So the marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of that variable among all individuals described by the table. And a conditional distribution of a variable describes the values of that variable among individuals who have a specified or a specific value of another variable. And there's a separate conditional distribution for each value of the other variable. And we can say that there's an association between two variables if specific values of one variable tend to occur in common with specific values of the other. So let's take a look at this example so we can understand these terms a little bit better. So this example is called cell phones. It says the Pew Research Center asked a random sample of 2,024 adult cell phone owners from the United States which type of cell phone they own, iPhone, Android, or other. And other would include non-smartphones. Here are the results broken down by age category. So we have three categories here across the top, and this is the age category. Okay. So people either fall from 18 to 34, 35 to 54, and 55 plus. Now, the reason we don't see anything less than 18 because we're only concerning ourselves with adults. Okay. And over here, this is another, okay, these are more categories here, but this is by type, the type of cell phone. So for example, this 169 people, there were 169 people aged 18 to 34 who had an iPhone in our sample. Okay. So, number one down here, it says use the cell phone data to calculate the marginal distribution in percents of type of cell phone. Okay, so we have three types of cell phones. When we see a two-way table, sometimes they give us total information, but sometimes they do not. If you do not see total information, it's always a good practice to total everything up. So let's total up each row. So if we go across, and you can do this with a calculator, we do 169 plus 171 plus 127, and we get 467. All right, let's do the same thing for Android. 214 plus 189 plus 100 equals 503. 134 plus 277 plus 643 equals 1054. And then if we add up all three of these, it should equal the number of people in our sample. So if I take 467 plus 503 plus 1054, I get 2024, which matches up with what they told me. So I feel pretty good about that. Okay. Now let's add down by age group. So 169 plus 214 plus 134, 517. 171 plus 189 plus 277. And again, I'm doing this on the calculator. That's 637. And 127 plus 100 plus 643, that's 870. Now if I add these three numbers across, it should also equal 2024. Let's make sure. 517 plus 637 plus 870, and it does indeed give me 224. So I feel pretty good about that. So what I've done, I've added things in the margin of the two-way table. All right, this information is in the right margin, and this information is in the bottom margin. So now let's actually go back to the question. It says, use the cell phone data to calculate the marginal distribution of the type of cell phone. So here's the types are in rows. Okay, so how am I going to figure out this as a percentage? How many people own an iPhone? 467. But the question is, what percent of people own an iPhone? Okay, So the way I could do that is I could do 467 divided by the total number of people, 2,024. So 467 divided by 2024, okay, that's 0.2307. So that's 23.07%. Okay. Then I would do 503 divided by 2024. As a decimal, that's 0.2485, so that's 24.85%. And then 1054 divided by 2024, that's going to equal 52.08. If I round. Now these, if I add these three numbers up, it should be pretty close. It should be 100%, but it might be slightly off because of rounding. Okay, it might be like 100.01 or 99.99 or something really close to 100%. So this right here, this is the marginal distribution of the type of cell phones. 23% own an iPhone, 24.85% own an Android, and 52.08% own another type of cell phone. All right. So number 2, it says make a graph to display the marginal distribution. Describe what you see. So I'm going to do that right down here. Okay. Now I can do, a different type of graph. So for number 2, I could do a bar graph, or I could do a pie chart. Okay, I'm going to choose to make a bar graph. Okay. So what's a good idea? A good idea when you make a graph, okay, start at 0 as you go up the axis. 1, 2, 3, 4, 5. And maybe each one of these tick marks represent 10%. So 10%, 20%, 30%, 40%, 50%. Okay. So this would be called percent, or more formally, this is called relative frequency. Okay, that's called relative frequency. All right. Down here, we can call it type. Okay, so I have 3 types of phones. I have iPhone, I have Android, and I have other. So when we make a graph, the bar for iPhone should be 23.07 high. So it's going to be above 20. So that might be 25, so 23 might be about right there. Android is 24.85, so a little bit higher, okay, a little bit higher than iPhone, but not by much. Okay, and the bars should all be the same thickness, okay, so the same width. And then the other is 52.08. It's going to be a little bit above the 50 mark. Okay, so I gave both axes a title. Okay, I gave both axes a title. Now both axes a label. I should give a title to this as well. All right, we can call this cell phone types of American adults. Now let's try number 3, because number 3 asks us to do a conditional distribution. It says, what percent of each age group is an iPhone user? So here we want to focus our attention on each age group. So in the first age group, there's 169 iPhone users out of 517. And the way we would write this conditional distribution, or this conditional, we're finding the probability, so I'm going to use a capital P, that a person is an iPhone user given that they're in the 18 to 34 age group. All right. So here's how we do that. How many people are in the 18 to 34 age group? Okay. There's 517 people. And of those 517 people, how many of them use an iPhone? 169. So let's calculate that percent. 169 divided by 517. That's 32.69%. Let's find the probability that the person's an iPhone user given that they're in the 35 to 54 age group. Okay, so now we're going to focus our attention on this column. Okay, of those, there's 171 iPhone users out of 637. Okay, so even though there's more users in the 35 to 54 age group, there's a smaller percentage, 26.84%. Okay. Then we have to do it for the last age group, and here, all right, so we want to find the probability that the person's an iPhone user given that they are in the 55 and older age group. So there's 127 of those people out of 870. So as a percent, it's 14.60% if I round. Now notice, these three numbers do not add up to 100%. Okay? So if we did a conditional distribution here, let's actually go through it for each age group. Okay? So here, we already found 169 out of 517. We said that was 32.69%. All right, 214 divided by 517, that's 41.39%. And 134 divided by 517 was 25.92%. Okay, so of all the 18 to 34-year-olds, that percent use iPhone, that percent use Android, that percent use some other phone. Okay, let's do the same thing for the next two age groups. Okay, we already know the first one is 26.84%. Then if I do 189 divided by 637, I get 29.67%. And 277 divided by 637 is 43.49%. These three numbers do add up to 100% because they make up 100% of this entire age group. Same thing here. These three add up to 100 because they make up 100% of that age group. I'm going to do the last column. I know the first one is 14.60%. I'm going to do 100 divided by 870. That makes up 11.49%. Then I'm going to do 643 divided by 870. and we get 73.91%. Okay, so just looking at those numbers, people that are 55 and older, they're much more likely to have some other type of phone, because this percent is way bigger than this one and it's way bigger than that one. Okay, as people get older, their use of iPhone goes down. All right, and same thing with Android. As people get older, it seems like their use of Android goes down. Okay. So the next question, it says, what percent, or excuse me, we just did this one. What percent of each age group is an iPhone user? So we did that. Number 4, it says make a side-by-side bar graph of cell phone type by age group by raw counts and percents. Well, I'm not going to do it by raw counts, and I'm going to tell you why I'm not. If we do things by raw counts, things are not relative to each other anymore. So for example, if I just did it by raw counts, 171, that bar would go higher than 169. But in terms of relative percents, in this age group, this is only 26% of the age group, while it's 32.69% of this age group. So it doesn't make sense when you do side-by-side bar graphs to do it by raw counts unless all of these totals were the same. If all the totals were the same, then the relative percentages would be the same way. Only if these numbers are the same should you ever do it by counts. You should always do it by percents. Okay. So I'm just going to do that on another piece of paper. Okay. I'm going to show you how we could make a side-by-side bar graph. Okay. I'm actually going to go this way with it. All right. Oops. Go a little bit here. There we go. Okay. So we're trying to make a side-by-side bar graph of cell phone type by age group. Okay. So since it's by age group, all right, down here at the bottom, we're going to have different age groups. And this first age group is going to be 18 to 34. Okay. And then in the next bar, 2, 3, we're going to have 35 to 54. And then we're going to have 55 plus. Okay, so I'm going to give this a label. This is going to be age group. And over here on this axis, we're going to call this percent again, or we can call it relative frequency. Let's see, 10, 20, 30, 40, 50, 60, 70, 80. All right, so 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%. Now, how did I know to go up to 80%? When I look at all of these numbers, all these percentages that I put into my table, the highest one that I ever see is 73.91. So I know I don't really need to go above 80. Okay. Now, for each age group, I'm going to make 3 bars. Okay. And I'm going to give a little key over here. Okay. In blue, okay, I'm going to do iPhone in blue. Okay. So of the 18 to 34 year olds, 32.69 are iPhone users. I'm just going to put additional little tick marks in here to help guide me just a little bit more. So of the 18 to 34, okay, And if I look back at this, I'm looking at this number now, 32.69. So 32.69, that's about right there. Okay. Now in green, I'm going to make Android. Right. And of the 18 to 34-year-olds, 41.39 use Android. So 41.39, that might be maybe about right there. And in red, I'm going to do other. And that's 25.92 in the 18 to 34-year-olds. So 25.92, that might be about right there. All right. So these three bars add up to 100% because it makes up 100% of the 18 to 34-year-olds. Now, in the next one, 35 to 54 age group, 26.84 use an iPhone. And I'm going to do iPhone in blue. So maybe that's about 26.84. See, it's a lot easier to do it by percents because then we're comparing apples to apples. The blue bar here is smaller than the blue bar here. Okay. Of the Androids, of Android, 29.67. So 29.67 is just a shade under 30. I think I drew it a little bit too high, but that's okay. Okay, so the green bar looks like it starts to get a little bit smaller, and other is 43.5. To make this one go up to 43.5, maybe that's about right there. Okay, so again, this is called a side-by-side bar graph because these bars are side-by-side for each group, in this case for each age group. And in the last group, 55 and over, okay, only 14.6% use iPhones. So 14.6 is a little bit less than 15. Okay, I'm keeping all the bars the same relative thickness. All right, 11.49% use Android. So that might be maybe a shade too high. Maybe that's about right there. And about 74% use other. So it's going to go way up. Maybe about right there. All right, let's give this a title. We can say American adults type of cell phone by age group. Okay, and you can see something, all right? These two variables are definitely associated with each other, okay? As people get older, their use of iPhones and their use of Androids diminish, but their use of other types of phones other than those two get higher. So these two things affect each other. So this is cell phone type. So if cell phone type is impacted by age group, or age group is impacted by cell phone type. Okay, these two are associated to each other. If all the red bars were about the same heights, and all the green bars were about the same heights, and all the blue bars were about the same heights for, as we look across age groups, then we would say there's no association. Okay, but these are vastly different heights of bars. All right, so this is a side-by-side bar graph. Okay, in your text they also talk about segmented bar graphs. Okay, so instead of making 3 bars, they could have made a single bar, and they could have segmented it off and put like this green part on top of the blue part, and then the red part on top of the green part, and then we would just have 3 bars, but each bar would have a total of 100%, but you could see how the blues are getting smaller. It would be a little harder to see how the greens are getting smaller. Okay, and same with the reds, because they kind of start at different places on segmented bar graphs. So side-by-side bar graphs are usually better than segmented bar graphs. All right, and that is going to do it for that lesson. Okay, so we did the Chapter 1 Introduction, and we did Section 1.1. So hopefully that helped your knowledge.